This instructional video is designed to demonstrate why water has a pH of 7, as well as the origin of the pH scale, and demonstrate the relationship between the concept of pH and pOH. Now, by definition, pH is calculated as the negative log of your hydrogen ion concentration. And in general, P of anything is negative log of that thing. So pOH is the negative log of hydroxide concentration. And if we wanted to, we could even calculate something like a pKa or pKb, where we take minus log of that respective equilibrium constant. So the other piece of information we have is that we have this reaction. Under normal conditions, water slightly ionizes into hydroxide ions and hydrogen ions. And there is an equilibrium constant value for this. We use the subscript W to refer to the K of water. And that value is 1 times 10 to the negative 14. So it's possible to set up an equilibrium constant expression for this, where we'll have that the K water is something that looks very much like a solubility product expression, because liquid water will not participate. And so we just have the product of the hydrogen ions and hydroxide ions. Now, if we take the negative log of everything, we get minus log of 1 times 10 to the minus 14 equals negative log of this product. Now we know from our product rules that we can separate these two into a sum of logs. And we know from our definition of a logarithm that the value here, because it's negative log, you're going to have negative of negative 14. So that gives us the value of 14. And here we have minus log of hydrogen concentration and minus the log of hydroxide concentration. Well, we know that this term is pH, this term is pOH. And so this gives us one way of determining pH if we only have hydroxide ions to calculate. We can just say that pH equals 14 minus the hydroxide, the pOH. The other thing to note is that because we have an actual value for K water, and we know that these two concentrations must be equal, when we use our substitution and solve that quadratic by taking a square root, what we'll find is that for water, pH equals exactly 7. So this forms the basis of our pH scale, showing that neutral water is right in the middle at 7, and that pH values between 1 and 14 are the ones that are most common. Below 7 you have more hydrogen ions, and above 7 you have more hydroxide.